everybody. So good to be here. So glad you're here. Cisco Live 2025. It's a good one. Are you having a good time so far, folks? I can't hear you. All right. Okay, folks. So when I was growing up, we had a show on television. I was in Canada. I was on the Discovery Channel. It was called How It's Made. Anybody here seen that show? Yeah. Fascinating show. Love it. They take a simple object, like a matchstick, and they show end to end how that thing is made. And you know what? It's so good, I still play it for my kids. It's on Amazon. And I play it for my kids. They love it. I don't think there's a kid around that can't watch that show with their eyes wide open. Just really enjoy that. In fact, on a recent family trip we had to Oregon, we stopped in at the Tillamook Cheese Factory, where you can walk out on a platform and look over the cheese factory and see how it's made, the cheese, that is. And so here's a shot, that's my son there, looking down over the cheese factory at the quality checkpoint, the last step in the process, where I thought it was funny, they have a metal detector there. Just one more check on the cheese, make sure no bits of metal got in there. I don't know why. I don't know what metal's getting in the cheese or what they're worried about, but it's there. Now, when I'm thinking about how it's made for our software products, I'm challenged a little bit because we don't have a factory. We don't have a platform you can walk out and look down and see the software getting made. What we have really is an idea factory. A lot of concepts that are coming together and working together to form what we call our software delivery process. It's a set of patterns. And the idea of patterns in software is not new. In fact, there's an old book called A Pattern Language. This guy, Christopher Alexander, who's an architect back in the 70s and wrote a lot about architecture and what it means to put together a system, what it means to build something. And this book inspired a very famous book in software you might have heard of called Design Patterns. Have you heard of that book? A couple nods, yeah. It was inspired by this right here. So what I'm going to talk to you about today are a set of patterns that we use to deliver software, to deliver secure access. It looks something like this. And the way I'm going to present it to you is actually a bit of a historical take on this, how these patterns came to emerge over a period of time of getting better and better at manufacturing, getting better at product development, and moving into the world we live today, which is software. I'm going to show you how all of these products, or all of these concepts, came to apply in the world of software. So you're going to walk away today with two things. One, you're going to learn how secure access was made and is made, and you're also going to learn a little bit about systems and how they're made. And I'm hoping that you'll be able to take away some of these things and bring them back into your own systems that you're building as well. A little bit about me. My name is John Rauser. I'm a director of software engineering at Cisco. Been with Cisco for about 6 years, and I'm currently focused on building the zero trust components and experiences in secure access. And I was very excited when somebody I talked to just as we were getting started, showed me the app, the Zero Trust app running on their phone. So that was really cool to see it out in the wild getting used. Now, for me, I am a very avid reader. I write a lot. I speak about these topics. I'm really passionate about ways of working, about how we think about software, about how to build great software systems. Here's a stack of books from my library. I actually wrote a paper just recently taking networking theory and applying it to organizational theory about how we build software. You can look at that on my website, and you can also reach out to me on LinkedIn if you want. If you find this interesting, you want to connect. Okay, so that's a little bit about me. Just one more thing. There is an app. You may have heard of it. You can go and use the app. You can log in there, and you can jump on a WebEx space with me. We can talk to each other on there. And one more piece of housekeeping. There are a lot of sessions on secure access here at Cisco Live, and I attended many of them myself. The top ones there are absolutely fascinating. Cisco IT's journey to adopting secure access. I see some nods already in the audience. You can check out the recordings in the video library after the conference. They're already passed, but they're really good sessions. The top two especially, Johnny Noble's session about the latest features we have, in secure access. That's the second one on the list. And then lots of specialty sessions about different aspects of secure access, the zero trust, the universal ZTNA, the enterprise browsers, and so on. So go and check those things out. Those will teach you a lot more about how these things are deployed and how they're configured and things like that. But today's talk is going to be a little bit different, and we're going to be talking about these patterns of software delivery and how they play out in secure access, okay? I do want to take a quick poll of the audience, though. Who here is a secure access customer today? Got hands. We got hands. And who here is thinking of deploying secure access or looking at it and considering it? Okay, more hands. I think that covers just about everybody here. In fact, if you didn't put your hand up, you might be wondering what you're doing in this room. I don't know. Okay. So where are we going to start? We're going to start at the start. We're going to start with a guy we all know, Henry Ford. Okay? Henry Ford is really the father of modern product delivery. Why? He created the idea of the moving assembly line, okay, where products move from the beginning to the end, and we work on them in steps. And he changed, actually, brought down the time it takes to deliver a Model T automobile from 12 hours to 90 minutes using the moving assembly line. Really interesting stuff. You've all heard of it. And you've all probably heard of this quote already, too, about the faster horse. See, Ford was also a visionary in terms of how he thought about products and about things that we're manufacturing, what we're delivering, and the impact we're having on society. And he didn't want to just build a faster horse. He wanted to build something that would change, reshape society, the way we live, the way we work, the way we build our cities and towns. And that's exactly what he did. And I think the metaphor is really good when it comes to secure access and when it comes to networking in general, because what are we trying to do? We're trying to get our users to the places that they want to go. And we've always had this problem of how do we do that securely? How do we put things in between where our users are trying to get to that will create a secure experience for those users? Now, the way we used to do that is how? Rack them and stack them, right? We'd have a stack of hardware, big iron in the data centers that's doing the deep packet inspection, maybe doing some proxying, doing the firewalling for sure, but we got that iron that we're deploying, and that's not what we're doing with secure access. This is not just a faster horse, okay? It's actually a part of a transformation. And if you are currently deploying secure access or looking at deploying cloud security solutions in your business, you know what I'm talking about. It's a transformation as you move to a completely different way of thinking about your network and thinking about delivering security to your users. It's also a different way for us at Cisco in thinking about how we deliver products to our customers, because we're not selling you iron anymore. We're giving you a cloud solution that you can depend on, that you can trust. And so you're getting all these features. And I think that why you're here today is you want to understand how these features are created and how we can guarantee that you're going to have a great experience when you're deploying this product, and same with your users as well. So I want to open up what might be a black box and show you a little bit about how we do that. Now, like I said, it's not a faster horse. We're not just racking, stacking the same boxes that you used to deploy on-prem. We've got a true cloud-native, cloud-delivered architecture that's leveraging all the key patterns that make great cloud services today, starting with our use of hybrid model for deploying our data centers. We use public cloud, we use WebEx data centers, and I do want to pump the tires on one of the talks yesterday. There was a how it's made style talk for WebEx DCs yesterday, which is fascinating and interesting. You should check out the recording of that too. They go quite deep in how the data centers are deployed. But for us here in Secure Access, we're deploying a lot of stuff on those data centers, and starting with the platform that we're going to deploy our services on top of. Now, it's interesting because if you're deploying network security services on commodity hardware and using off-the-shelf components, which is what we're doing, which is what creates the experience that we can deliver, it doesn't just work out of the box. Kubernetes is not designed, for example, to run real-time security workloads. Kubernetes is an excellent container orchestration pattern, or I should say platform, that helps us execute on a lot of the patterns that I'm going to talk about today. But it wasn't just built for network security, and it wasn't built for real-time workloads. So we actually have to customize that to make it work for the cloud, to make it work for these cloud-delivered security solutions. And as we move up the stack, Again, we want to deliver all these things, our security services themselves, the traffic acquisition capabilities, the management and configuration. We deliver those sort of as a single service using microservice architecture, using infrastructure as code, using automation, and using true cloud-native capabilities. And that's what we're doing here with Secure Access. So I want to tell you a little bit more about how, now we've sort of set up the product, how we do that, how do we deliver with these capabilities. Now the first thing, and the most important thing, is quality. Here's the thing about quality though. In the history of work, in the history of building products, quality wasn't always the most important thing. It's funny to think about that now, because how often do things break, that the chairs that you're sitting on, the vehicles that we drive, but quality wasn't always something that was built into our systems. It's something that the world had to discover. And one of the major ways, the biggest influence on quality, almost everything that you see around you, almost everything that's manufactured today is influenced by this, the Toyota production system. Who here's heard of that? TPS, Toyota production system. Less hands, okay. Really fundamental system that came out of the post-war era in Japan as they're reconstructing their industry, reconstructing their country, and learning how to build products and learning how to manufacture things with really low tolerance for error. And it's influenced in a lot of ways the things that we do in software today. I love this quote from Deming, who brought the Toyota production system to America in about the 80s with this book, Out of the Crisis. America was having a huge crisis with manufacturing, quality problems, and Deming brought this philosophy and these concepts of the Toyota production system to our own manufacturing systems here in America. And that idea that quality is everybody's responsibility, that it goes up and down the stock, that there's no quality checkpoint with a metal detector at the end. There is quality that's built into every step along the way, is so important to us with Secure Access. So we've developed what we call the layered quality framework, which makes sure that at every step along the way in developing our software, we're looking at quality and we're looking at how we can guarantee and make sure that we have high confidence in the products that we're delivering. So it goes up the stack from in the development phase into when the components come together, into how we think about end-to-end, how those components are going to deliver an end-to-end experience. And then, for you, the customers, how you're actually experiencing them and listening to what you're saying and responding to your feedback. So this all comes together in what we call the layered quality framework and plays out in everything that we do. It's fundamental to our whole process. The next thing that is absolutely critical and fundamental is a focus on design. Now, again, design wasn't always something that was at the forefront of how people thought about product development. It had to be discovered through a history and an evolution of work management systems. Today, we think a lot about design. In fact, Cisco has become a very design-focused company. And I hope you notice that across the portfolio of products at Cisco, the design and the usability has become #1 concern and has really, really evolved and changed a lot. Jeetu Patel, president and CPO of Cisco, has a maniacal focus on design. It's a #1 priority, removing friction and keeping things simple. And I believe that we've executed on that really well with Secure Access. Because if you look at what we're doing in Secure Access, it is a user-focused, admin-focused experience. We've created our unified policy where you can set up access policies easily that have both internet and private access. We easily onboard you with our VPN experience that we've redesigned and I think makes it a lot easier to deploy VPN. We've got our zero trust experiences that tie in with that. And so you can migrate your VPN to the cloud and begin your journey into cloud security, and then start adopting Secure Access using capabilities like resource discovery to discover the resources on the VPN, and then set them up for zero trust access using that app that I talked about earlier. All of this is made insanely simple with our UI. In my opinion, I think in many of the opinions of the customers and the people that are here today, the people that we talk to. But it's not just about the user experience. We're talking about how it's made, right? We're talking about also the developer's experience. We want to make the developer's experience that's working on these products really good as well. So I'll give you one example of that. One of the challenges with running high-performance network security applications is achieving that high performance on commodity hardware. So one of the things we've invested in, we've actually open sourced this. You can look it up right now, go to fd.io and check out our software-defined data plane that powers almost all of our components in cloud security. This is the way that we handle packets. This is the way that we process the network stack as we're pulling packets from the platform that you saw earlier, the platform into the security services, or from the acquisition services into the security services. Every component in our system is using something we call VPP, vector packet processing, which is a way of bypassing the kernel in the operating system and getting user space, so the software, the security services that are running in user space, direct access to the network. It's really fascinating stuff. Check it out. Check out that fd.io, and there's lots of people that are using this now as well. And we've open sourced this component, made it easy to use, make it easy to work with, made it easy to build systems on top of, and lots of people out there in the world are starting to look at this too as a way of solving these problems. So this is an example of how we're also focused on delivering great designs in the developer experience as well. Really important. The next concept I want to talk to you, going a little bit later, now coming sort of into the modern era, is flow. Does that ring a bell for anybody? Do people here think about flow, or is it just me? Okay, it's just me. I'm kind of like a work management systems nerd, so bear with me, folks. So flow is the idea that we want to get smooth, continuous delivery of value into production, into the hands of you, our customers. So how do we do that? We have a practice called continuous delivery. Now this might ring a bell. Some people are familiar with continuous delivery in this room? Yeah. So continuous delivery is the practice of making small changes and delivering them one at a time into a production-like environment and building the system with those small changes. No big bangs where we're pushing out a big batch of changes all at the same time. What we want to do is make a continuous flow of small changes. We call that continuous delivery. And this is actually the cornerstone and a really important part of our quality strategy, because every single change that we make goes through our full quality framework that I described to you earlier. And we analyze and we look at those changes one at a time. So it allows us to get fast feedback, it allows us to easily figure out where things are going wrong, and it allows us to deliver systems a lot more safely into production. So we're always going from a working system to a working system. We're not accumulating a bunch of things and then trying to push something out that we're not confident in. I love this quote from John Gall, who says, "A complex system that works is invariably found to have evolved from a simple system that works." Makes sense, right? That's how nature works, and that's how we think about building our software systems as well. I saw some nods from the audience there with that one. It's good stuff. Okay, we also evaluate ourselves on our continuous delivery practices. We want to make sure that we're doing it correctly, and we want to make sure that we are assessing whether we're doing it correctly. So we have a number of evidence-based KPIs that we use to measure the performance of our continuous delivery process. These are based on grounded in large-scale empirical research. They're not just an opinion, it's not just a trend, it's actual research that was done on continuous delivery and the leading indicators of how well you're doing on that. So we evaluate ourselves in these categories and make sure that we're showing up in the elite category. It's really important to us as well. The next thing we're going to talk about is resiliency. Now resiliency is quite simple. Resiliency means that we want the system to be able to maintain it in the face of disruptions. We want, if there's unexpected conditions that occur, we want to be able to recover gracefully. And so we need to also build resiliency into the system. And I love this quote from Nassim Taleb. I'm a huge fan, very interesting author. He says, "Things designed by people without skin in the game tend to grow in complication." We don't want things to grow in complication. We don't want them to become complicated. We want them to remain simple, easy to understand, easy to work with, right? So how do we do that? How do we build skin in the game into our systems? Well, we have this thing called on-call. Who here's gone on call before? Yeah, who here goes on call today? Okay, there's a few. Who here likes going on call? Nobody, okay. So going on call is what I think gives engineers real, tactile, feet on the ground experience with the systems that they're building. It's absolutely critical. And here's the thing about cloud security. Here's the thing about secure access. Everyone goes on call. The engineers are responsible for the code they write, the changes they make. It's this quote from Werner Vogels, who is the CTO of Amazon. If you build it, you run it. You go on call for it. What does that mean? It means that we have to prioritize going on call. We don't want on call to be a terrible experience where I'm confused, I don't know what to do, I don't know how to follow this or what this means. So we spend a lot of time thinking and executing really well on our ability for our engineers to go on call at all these different levels. At the individual level, the team level, the way teams come together as a group, and even the architecture of our products is designed with going on call in mind. It's so important because it gives people that skin in games and makes them responsible for the decisions that they make. That's what you want as our customers, right? You want us to be responsible for the decisions that we make and not just be able to shelf it. Oh, it's done, it's over there now. So, everything we do when we build a product, I've got it listed over there on the right, everything we do is shaped by how we go on call. Here's a little snippet from back when I was a frontline manager, and when I was always on call. So the way it works is you have a 10-person team, you have a 10-week on-call rotation. Each person goes on call every week, but they need a backup. Somebody to call in case they don't know what to do, or they get confused, or they need some help, or they need to pull in other teams. So that was me. I was the frontline manager, and I was always on call. I did that for years. And like I said, everybody goes on call. The engineers go on call, the managers go on call. We're all responsible for our decisions. We're responsible for our risks, and are responsible for our outcomes. How do we go on call? It's really, it's a collection of these things here. First of all, we have monitors on everything. I mentioned that single piece flow earlier. Every time we make a change, we make sure that change has the right monitoring on it so that we know how it's operating when it goes into production. We have literally thousands of monitors running on our systems in Secure Access that are all writing back to our observability systems, which, by the way, is now Splunk. So Cisco acquired Splunk, as you know, and we moved to Splunk. Folks, I'm not trying to sell any Splunk today. I'm not, but we're loving Splunk. It's really good as an observability tool. We've got all our logs and metrics going into Splunk now, and we're using that. We've actually deprecated our old systems. We're loving Splunk. So check it out. But every monitor is writing logs and metrics, and every monitor means something. It has a threshold. And when it hits that threshold, you have an alert. So the monitoring systems have alerts, and then what happens when the alerts go off? Well, you need to know what to do. So every alert has to have a runbook. This makes sure that something's firing, something's going wrong, you know exactly what to do, exactly what steps to follow, and it's easy to do that. And the great thing about how we think about on-call too is that when you go on call, part of your responsibility is to leave it better than you found it. So that means tuning the alerts, maybe writing some new monitors, updating the runbooks, but always, during that week when you're on call, you leave it better than you found it. You leave it better for the next person who's going to go on call. And that creates a virtuous feedback loop that's really important in our systems as well. I will touch on this for a second. AI, very practical standpoint. AI is helping us in changing the way we think about these things. AI is helping us cover more cases on our tests when we're writing tests. AI is helping us with correlating signals, and it's really good at finding anomalies. This isn't just, this isn't smoke and mirrors, this is real stuff here. We're using AI actually to help doing all these things better. When an alert fires, we can have an agent go out and collect the logs and get the system ready for us so the engineer can go and have something to look at right away, reducing the time to value, reducing the time to resolve on those things. So AI is actually having a big impact here for us, and it's really interesting. If you want to hear more about that, please reach out to me, because it's fascinating stuff. There's lots of stuff that is easy to implement, low-hanging fruit, big gains. Let's talk about the next thing, reliability. Reliability means when things are operating at scale, are they going to maintain performance, scalability, and all that kind of stuff? So there's a key sort of inflection point in software delivery was the publishing of this book by some of the people that worked at Google on SRE, Site Reliability Engineering. And just people know what I'm talking about when I talk about SRE. Do we have any SRE people in the room by any chance? No, okay. But you have people, probably a lot of you are thinking about a lot of the things that you have to think about here, running things in production, basically bridging the gap between the changes that we're making to the system and how that system operates long-term in production. So the great quote from that book is, hope is not a strategy. There was a point in time where that was the strategy for a lot of the systems that were built in the world. I hope they work at scale. That doesn't cut it anymore. That's completely unacceptable. We need a reliability strategy around that. And it's a lot of thinking about these things here. How do we automate? How do we manage our capacity? How do we monitor our capacity? Tooling and practices around all that kind of stuff, around automation and capacity management. How do we do our deployments so that they're safe? How do we do our a region build out so we can come up quickly in a region if we need a new region? By the way, we're doing that really well with Secure Access. We were able to put up regions now in a matter of days. And we've expanded our regions, I think we were at 12, keeps going up. 12 last year when I did this talk. It's gone way up now. I don't know the exact number. I think it's a lot higher. What's that? 18. And we keep adding them. It's also about our data center strategy. So how do we achieve high reliability in our data center footprint? So we have this multi-layered system that a lot of cloud providers use today, which is load balancing using, and placement of loads using DNS into different regions, and then within a region, multiple zones that can rotate in and out invisibly without people noticing. So with this strategy, we can replace a zone if we need to. We can even replace a region if a region goes down. And you know what? When you're running on AWS, nothing is guaranteed. If you think, I mean, they don't have a lot of outages, but AWS even does have outages. We're able to pull our system out and respond to that very quickly, very easily, and move all traffic over to a different region if we need to. So managing that capacity and managing sort of the statistics and the probabilities around things like that happening, that all falls into the site reliability engineering domain. There's another aspect of our systems, which is how do packets get around the world? So you may have private applications that are connected to US East, and you have your users that are connecting to US West. How do they get there? What if those users go to Europe? And they're still able to access those applications, even now when they're connecting in Europe. So we have our global backbone, which is our very internal BGP network. We have our own AS that we run, and we distribute load and traffic across the world and make sure all those packets get to where they need to be. Users can connect to their applications no matter where they go. And part of managing that is site reliability and making sure that this backbone is always active yeah. So that's the site reliability piece. Let's move to the last two sections here. Two more things that I think are all-encompassing of everything that we've discussed so far. The first is systems thinking. So systems thinking is a way of looking at the world as not just a set of parts, but an interconnected system of things, right? Which includes not just secure access, but also how we connect into your network. So you're setting up IPsec tunnels into our network. You've got users that are connecting via VPN, maybe via Zero Trust, and they're some backhaul, maybe using resource connectors or IPsec. We have to think about that as a whole system, and not just our system and your system. And we sort of, I like to think, work together to deliver that functionality for your users. So one of the key ways this plays out for us when we're building secure access is thinking about troubleshooting. How are we going to be able to troubleshoot with you problems that might arise? So problems might arise on the user's computer. They've got AnyConnect installed, the secure client. They've got a bunch of other software running on there too. How many of you are running secure client today? A lot of you, yeah. When you have a problem with your endpoints, what is the first thing that we ask you to do? Just quick, shout it out if you Dart. Who said it? Okay, you get a prize. Don't know what it is yet. Dart. We asked you for a dart. Why do we do that? Why do we want you to give us a dart? And you know, by the way, if you're ever having a problem with an endpoint, just get the dart in there. Give us the dart right now. Just think immediate dart. Okay, got to bring the dart. Yeah. Whew. Let's throw a dart. Why do we do that? Well, we're trying to troubleshoot the whole system, and we're trying to reduce the footprint of that troubleshooting. So think about it like this. There's something in computer science called a binary search versus a linear search. A linear search is when you start at one end and you start hopping along one thing and checking each thing. Check, 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 check. So there's 20 things, and the thing is on the last step. You have to check 20 times. If the thing is on the first step, well, you got lucky. But you don't know. So we're trying to actually do a binary search. And a binary search is where you cut the system in half, and then you cut the system in half, and then you cut that system in half, and then that system in half, and you're narrowing down the search space. And that's what we try to do with you when we're troubleshooting. We're trying to eliminate areas of the system and reduce our search space so that we can much more quickly than, say, a linear search, get to the root of the problem. So we want to be able to first eliminate that computer. And then we might want to be able to eliminate your infrastructure. So we might ask you to run a PCAP on your infra. And then we've cut off that whole section. We don't need to worry about that anymore. So now we're going to move to a different section, maybe the backhaul, and maybe something in the middle. Maybe it's a policy issue. But we're trying to eliminate different parts of the system and get to the problem. There's also some capabilities that we've launched with AI that help do that as well. So I don't know if you've noticed, but we've got our AI assistant that's running in Secure Access for those of you that are using it today. And we've just launched some new capabilities around both troubleshooting. So it's pretty cool that you can go in here and you can put the different attributes of what you're looking for in there and then get AI to help you and search through the system and narrow down where the problem is. Similarly with experience insights, you can use the AI assistant to help understand what your user's experience is like based on Thousand Eyes that's running on the endpoints, and that is testing that experience constantly for all your users if you have Thousand Eyes deployed. So really fascinating stuff going on in the AI assistant space that helps with this troubleshooting and this overall kind of systems thinking approach to how we deliver our systems. We're coming to the end here, folks. We're coming to the last thing, which is I consider to be extremely important. I hope you all do, which is learning. In fact, you're here today. You're here at Cisco Live. Why are you here? You're learning. And it's not just an individual thing. It's an organizational thing. So we want to build what are called learning organizations, a place where people are continually discovering and learning about their systems and then changing them in appropriate ways and improving them over time. This book here is a great book that outlines 5 different disciplines for cultivating a learning organization. And we execute those on a number of different ways in Secure Access. But what I want to highlight is this one, incidents. Incidents, they happen from time to time, and they are some of the most rich learning opportunities for an organization and for the people that are building a system. Because incidents are when something unexpected happens, something that didn't match with the way that we thought our systems are supposed to work. So we consider incidents to be extremely rich opportunity to learn. And we practice that learning. So for example, we'll run fire drills, we'll run chaos experiments, we'll do things in our own private networks. And even with Cisco IT, we've got a separate network and a separate group of users that are off to the side in what you might call a dog food or a champagne environment. we call it drinking your champagne. I don't know what the dog food thing's not so great. But we run those experiments and we practice what it's like to have an incident and how we respond to it. Because here's the thing. Incidents happen because of something technical in the system, right? Something's gone wrong. But the way that we respond to an incident is so critical. The way that we can understand what's happening and then put a fix into place, we want to reduce that time to as low as possible, right? You don't want to sit in an incident. So how do you do that? Well, you practice incident response. The other thing we do is we develop a skill around incident analysis, which I call like one of the most critical things around incidents together is actually understanding what happened after the fact. What can we learn? What can we take away from that? And again, it's not just about the technical thing that went wrong in the system. It's about how people understood what went wrong in the system and how we can improve that understanding. Because quite often it's it's a mismatch between how I think about it, how it's supposed to work, and how it actually works. So we want to learn from that as well, not just the technical side, but the human side of incidents. So important. And I use this as an example to kind of highlight the depth that we think about our organization as a learning organization. I will shout out to that paper there. You can catch that link. It's a really fascinating analysis of how to think about incidents and how to think about what we do when we respond to incidents. So definitely check that out as well. Okay, so folks, we're coming to the end. These are the patterns of delivery that I felt really communicate a lot about how we think about building secure access. I hope that you've taken away something today. What I didn't want, and when you think about secure access, I don't want it to be just a black box. We want you to understand how we work and how we operate these security services. And we know that you're trusting us when you deploy secure access. You're trusting us with your network. You're trusting us with your users. And we want you to know that we are your trusted partner in delivering access and security to your business. We're walking with you, and we're thinking with you, and we're solving these problems together. That's what secure access is. It's not just a set of functionality. It's actually, it's us working together to delight your users and delight you as an admin. Make sure that the experience you're getting is exceptional. So, if you enjoyed this talk today, I encourage you to fill out the session evaluation. There's also some ways to contact me down here, an email address, and my LinkedIn. You can reach out as well if you want to talk about some of the things you've heard today, explore some of these ideas. I'm always happy to do that. And thank you very much. Cisco Live 2025. All right.